Okay, now so far we've only looked at specializing on functions, but we can also specialize class declarations. For example, maybe I want to specialize a special array object. And here, again, I have the same template keyword, and then in brackets, the type name T that I want to use to specialize. But then instead of defining a function afterward that uses type name T, I define a class. And so I have my class keyword, I have the name of the class, and then in braces, I have everything I want to create. And in this particular templatized class, I'm going to make an array of type T that has 10 elements. And now I can use this class to make an array of length 10 anytime I need one. So for example, if I were to specialize this class, I could declare lots of variables that are arrays of given types. So like TArray, I can specialize it to int, and then this IArray variable inside of it would have an array called value that had 10 integers. Like this DArray variable inside would have type TArray double, and inside of it, it would have an array of doubles, an array of 10 doubles. Or this SArray inside of it would have an array of type sumInt of length 10. And each three of these variables have a different type. The first one has TArray specialized to int, the second one has TArray specialized to double, and the third one has TArray specialized to sumInt. They are not the same types. They look like the same types because they came from a template. But remember, the template is a pattern, and when we specialize it, the compiler creates something new. It creates a new type from that pattern. And in this case, we're actually creating different classes. And so in these three variables, we create three different classes, each specialized in different ways. So for example, I couldn't copy a DArray into an IArray. That wouldn't make sense. Can't copy a DArray into an SArray. Those are different types. You can't copy from one to the other. I can implement type converters to convert from one to the other, but that's different, right? So these are all different types, and they have different types of variables inside of them because they're all specialized on T. I can even make this a little more interesting. I could, instead of having length be fixed at 10, I could add another parameter to my array, another parameter to this template called length that has a default value of 100, but which I can specify to be any length I want. So for example, my TArray int declaration down here says set T equal to int, but just reuse length equal to 100. And so IArray will have an array inside of it of type int, but a length of 100. Okay, but my double array here, DArray, I specialize it to have T equal to double, but length equal to 50. And so its array will have length 50. And then the sumInt array, SArray here, I specialize its length to 10. So it will have an array of only length 10 inside of it. And this 50 and 10 actually become part of the type. So if I had a different class that had doubles inside of it, specialized T to double, but specialized its length to 200 or length to 1,000, those would be different types, and they wouldn't be interchangeable, right? I couldn't pass a DArray to some function that wanted a TArray specialized on double with a length of 200. I wouldn't be able to do that because the compiler would see them as different types and would not see them as being compatible. Now, what this implies is that we can make any of our classes generic and specialize them on some type. And one of the things that would be really useful for us to do would be to make our list class generic, because then we could use it on any kind of type we wanted, not just on that item type that we came up with. So what I can do is inside at the beginning of my list class, I can add this keyword template type name item. And now everywhere I'm using item is now referring to this templatized type, and is now something I can customize and tune to be any type I want. And so that means in the same program, I could ask for a list that contained integers, because now everywhere I had item, it just becomes integer. Or I could ask for a list that contains strings. And I can just declare these and start using them. and they're both based on the same code. Basically, the compiler, again, when it sees these declarations, it'll create one version of my list based on ints, and it'll create a different version of my list based on strings, and they can coexist in the same program. There'll be different classes that it fully instantiates for these different kinds of objects. Okay, and then I can use them in my program. I can use the same code, the same list code, for any type of list I want. Okay, we could also extend our queue and stack to be based on templates as well, and to then use that list internally. I do want to bring up a side note. It's very common when you implement a big class like list to just implement the entire template inside the class, inside the templatized class declaration. You just put everything in there. But if you don't want to do that, you can actually implement functions out of the class for templates as well. The syntax gets a little bit clunky. What you have to do for an out of class definition is you have to include the template type name item keywords in front of the function definition. And you have to add this list, the name of the class, which in this case is list, with the template argument in brackets in advance of the function name you're implementing. And that tells the compiler this is for a template and it's templatized on item. And that way the compiler knows how to connect this function back to the prior template declaration that it saw. Okay, so in summary, templates allow us to write objects and reuse them for many different types of data. This is much better than writing many different versions of the same data structure for each kind of object it holds. That would get tedious really quick. Okay, we've already seen some templatized objects this semester. We just didn't really know what they were, like vector. Standard vector, you can put anything in that vector you want just because it's a template and it will accept it. And in fact, a lot of the code in the C++ standard library are templates so that you can customize them and reuse them in a lot of different ways. And you can usually identify templatized objects by brackets on their type name. Anytime you see that less than, greater than, right after the name of an object, that's a clue that it's a template and that you can specialize and change how that object works in some way.